Hey y'alls! Alright, I'm going to be teaching how to do number 4 of the chapter 18. This is entropy change. Alright, so the question is, calculate the entropy change when 4.35 grams of liquid bromine is heated from 30 degrees Celsius to 50 degrees Celsius if the molar heat capacity of liquid bromine is 7.1 kilojoule per mole times Kelvin. So the first thing we want to do is we're going to want to calculate the amount of moles in the 4.35 grams of liquid bromine. So remember that liquid bromine exists as Br2 liquid, right? And what we're going to do is we're going to say, alright, if we have 4.35 grams of bromine 2, and we want to find moles, we're going to have to use the molar mass for Br2. So you get out your handy dandy periodic table and you find that bromine by itself is 79.9 grams per mole, and so you just multiply by 2 and you get 159.8 grams per 1 mole of Br2, right? And this is grams of Br2, right? And you calculate that out and you say that it is 0.0272 moles of Br2. Okay, so now what you're going to do is you're going to say, alright, if that's how many moles I have, and we have a change in temperature, heat must be added, right? Especially if the temperature is going up, we must have put in heat, which we can say Q, right? And we say, alright, well, I know my molar heat capacity, right? Q is equal to basically heat capacity times moles times change in temperature, right? And so what we're going to do is we're going to say, alright, so I have 75.1 kilojoules per mole times Kelvin. And so the thing is, with Kelvin, what we can actually do is, since we're using change in temperature, we can actually say per mole per Celsius, right? This is only applicable when we have a change in temperature. And now what we're going to do is we're going to say, alright, we have 0.0272 moles, and we have a change in temperature of, I believe, what is that? That is 20 degrees Celsius. 20 degrees Celsius. Right? And so you multiply that out and you get you get 40.887 kilojoules, right? And that makes sense because our Celsius cancels, our moles cancels, and you're left with kilojoules. So what happens now is you say, alright, so that's how many kilojoules was put in. And so what we're going to do is we're going to say, use the equation delta S is equal to Q over delta T. That's just your standard change in entropy equation right there. So we plug in Q and we plug in T. And again, since it's a delta T, we can just keep it in Celsius. And we say, alright, we have 40.887 kilojoules, and we had a change of 20 degrees Celsius, right? And you get delta S is equal to, now the thing is it positive or negative? Since we had an increase in temperature, that means that we had a positive change or a positive input of heat, and our change of temperature was positive because temperature went up, so our delta S is going to be positive 2.04 kilojoules per degree Celsius. We can call it Kelvin because, again, it was a change in temperature. And is that what they asked for? They asked for joules. Okay, so you're going to have to convert into joules, and you say, alright, well, I know 1,000 joules is equal to 1 kilojoule, so you just multiply by 1,000 and you get 2,444 joules per degrees Kelvin is equal to your delta S. Alright? Awesome.